All right, so we got some more derivatives for you. So we have a chain rule here, right? We have a function inside of a function, right? So the derivative of the tangent of u, tan u, is going to be the secant squared of u times u prime, right? So we're going to get dy dx equals secant squared of u, the inner function, cosine of x. And then we're going to multiply this by the derivative of the inner function, derivative of cosine, which is just negative sine of x. Right, so just be careful. We're not multiplying cosine and sine at all here, right? Cosine is part of the secant. If we want to rewrite this a little bit, negative sine of x times the secant of cosine of x would be a cool way of writing it. That's what the kids are doing nowadays, from what I hear. So for question number 5, we actually have a quotient rule and then just the regular derivative. So this first part, x squared plus 1 over sine of x, right? That's going to be our quotient rule. Again, there's 5 terms connected by subtraction. In the top, we have our bottom squared. Let's just get this thing out of the way early because that's pretty easy. Oh, that's 5e to the x. Never mind. I'll come back to that guy in a second. So we have sine of x in the bottom. Sine of x is our first term. X squared plus 1 as our third term. And now it's time for derivatives. So we would take the derivative of x squared plus 1. That is 2x. And we take the derivative of sine, which is cosine of x. Again, nothing really simplifies nicely in the top, so I'm going to leave it like that. So this is not 5e to the x. No, no, no. This is 5 raised to the u, right? So I have an exponential function. Just recall that the derivative of something to the u is going to be u prime times the original function times the natural log of whatever that base is going to be. So we're going to get plus. So our u is going to be e to the x. So we're going to take the derivative of e to the x, which is just e to the x. We're going to multiply this thing by the natural log of 5. That's going to be a constant. And then we just have the term repeats, 5e to the x. All right, so that would be our question 5. Question number 6. All right, so we have a square root of u. As you undoubtedly recall, the derivative of the square root of u is 1 over 2 square root of u. So we just take whatever we have, bring it to the denominator with the 2, and then we multiply by the derivative of the inner term. All right, so this means that r prime of x, we're just going to bring what we got down to the bottom. There's 2 of them, e to the x plus the sinh of x. And then we just have to take the derivative of the inside, right? That's going to be nice because we're adding. Derivative of e to the x is e to the x. The derivative of the sinh is the cosh. And so there's our derivative. And then maybe I'll do, we'll do one more of these things in this video. All right, so here we have a product rule. So dy dx, product rule, 4 terms connected by addition. All right, so we know 2 of them, natural log of x, e to the cosine of x. So then we just have to take the derivative of the other parts. All right, so we'd have the derivative of e to the cosine of x. That's going to be a chain rule, spoilers. And we have derivative of natural log, which is nice and easy. It's 1 over x. All right, so e to the cosine x, well, we saw a moment ago that e to the u is just u prime e to the u. So we're going to get the derivative of the top, negative sine of x, e to the cosine of x. Could I clean this up a little bit? Sure. Will I? You got it. So negative natural log of x, sine of x, e to the cosine of x. We have another e to the cosine of x over x. Whenever you have exponentials, if you want, and if you don't want, I don't care, you could always pull the exponential out, right? We'd have negative natural log of x times the sine of x. This e to the cosine got pulled out. This e to the cosine, whatever, got pulled out. So you could also just write it like that if you wanted to, like, I don't know, impress your friends. So I'll do the next 3 in the next video.